students, in the previous lecture I have discussed about data envelopment analysis. In this lecture I am going to discuss about the game theory. I am going to solve this game theory problem using linear programming problem. So, I am going to formulate with the help of LP models that I am going to solve using solver. So, the agenda for this lecture is application of linear programming problem for solving game theory. This is an example of game theory. There are two players, they are playing games. So, in game theory there will be two players, the players A, player B. So, each player select one of the several strategies without knowing in advance the strategy selected by other player or players. That is an assumption. We call it as a two persons zero sum games. There will be two people will be playing. So, one person's gain is equal to another person's loss. So, the net of that game, the net effect of that game is 0. That is why we call it as zero sum games. So, zero sum means that the gain or loss for a one player is equal to the loss or gain for the other players. I have taken one sample problem. This problem is taken from the book Anderson et al. There are two companies which are competing for market shares. Two companies are only one manufacturers of a product. These two companies are having three strategies. One is they can increase the market share by strategy 1 called increase advertising. If they increase advertise, market share will increase. Second strategy is provide quantity discounts. When they provide more discounts, there will be more sales, that will increase their market shares. The third one is extending the warranty, providing more warranty for the products. So, people buy their products assuming that there is a warranty. So, there are three strategies for increasing the market share. Now, I brought the payoff table. So, here we have the company A, company B. The company A have three strategies called A1, A2, A3. The same strategy is available for company B also, B1, B2, B3. There are some values inside these boxes. I will explain what is the meaning of this value. So, the interpretation of payoff table is, if the company A increases advertising, if the company A go for A1 strategy and company B increases advertising, say B1, company A will come out ahead with increase in market share of 4%, while company B will have a decrease in market share of 4%. So, look at this is maximizing the gain. The company A, when you look at this table, the company A will look at this table, these are the gains 4, 3, 2. In the B's perspective, so this is A's perspective, in the B's perspective, whatever value it is appearing, it is a loss. The company will try to minimize the loss. So, if the company go for A1, company B for B1, so the 4 is the gain for company A, the 4 is loss for company B. On the other hand, if the company A provides quantity discount A2 for example, and company B increases advertising B1, the same thing, company B is still in B1, but this company A go for A2, company A will lose 1% of market share, while company B will gain 1% of market share. This is the way to interpret this table. Therefore, company A wants to maximize the payoff, that is its increase in market share. So, company B wants to minimize the payoff, because the increase in market share for company A is a decrease in market share for company B. That is why we are calling it as a zero sum game. What is the logic of this game theory? Each company will select one of its 3 alternative strategies. It can go for A1, A2, E3, A3. Similarly, B can go for B1, B2, B3. Because of the planning horizon, each company will have to select its strategy before knowing the other company's strategy. Okay, that means they are choosing in advance. What is the optimal strategy for each company? That is the solution we have to give to the managers. The logic of game theory assumes that each player has the same information and will select a strategy that provides the best possible payoff from its point of view. When A looks at the table, the A will try to maximize gain. Company A selects strategy A1, the market share increases of 4%, 3% or 2% are possible depending upon company B's strategy. So, the 4 is possible when company B go for B1, player 3 is possible when company B go for B2 and A plays A1. Okay. At this point, company A will assume that company B will select the strategy that is the best for it. So, both the people, company A and company B, will try to choose the best strategy for them. Thus, if company A selects strategy A1, suppose the company selects strategy A1, the company A will assume that company B will select the best strategy. So, for B, which is the best strategy, the company B will minimize the loss. The best strategy is B3. So, that is the meaning. Company A assumes company B will select the best strategy B3, which will limits company's A's increase in market share to 2%. So, player B will try to limit the gain of the gain of the company A, that is they will limit not to have more than 2% gain. So, continuing with this logic, company A analyzes the game by protecting itself against the strategy that may be taken by company B. Doing so, company A will identify the minimum payoff for each of its strategies, which is the minimum value in each row of the payoff table. Why we are going for minimum value in each row? Because company B knows that company B will limits the profit of gain of company A. So, the company strategy for player A. So, I will explain what is this maximum, but at present row wise we are going for choosing this 2, row minimum is 2 for strategy A1, for A2 it is -1 and A3 it is -2. After comparing the row minimum values, company A selects the strategy that provides maximum of the row minimum values. Okay. That strategy is called maximum strategies. What is the meaning of maximum strategies? Company A will try to maximize its minimum gain. This strategy is called maximum strategy. Okay. What we have done? Row wise we have find the minimum values. So, 2, -1, -2. Out of this, which is maximum? This 2 is maximum. So, this point is called maximum strategy. Thus, company A selects strategy A1 as its optimal strategy, that is an increase in market share of at least 2% is guaranteed. Now, look at the B's perspective. The entries in the payoff table represents the gain in the market share for company A, which corresponds to losses in market share of company B for company B. Consider what happens if company B selects B1. Suppose company B selects B1. Company B market share decreases by 4%, -1% and 5%. This is the loss. Under the assumption that company A will select the strategy that is best for it, company B assumes company A will select A3, resulting in a gain in market share of 5% for company A and a loss in market share of 5% for company B. So, at this point company B analyzes the game by protecting itself against the strategy taken by company A. Okay. Doing so, the company B identifies the maximum payoff to company A for each of its strategies B1, B2, B3. So, here what will happen? This company A, right, will always try to maximize its gain. Suppose the B go for B1, company A will go for A3. If the B go for B2, company A will go for A2. If the B go for B3, company A will go for A1. Okay. So, here the B is going to follow a strategy called minimax. So, we are finding the maximum loss column wise. For example, B1 maximum is 5, B2 maximum is 4, B3 maximum is 2. So, company B will try to minimize its maximum loss. First we have found the maximum loss, in that which is minimum, the 2 is minimum. So, this strategy is called minimax strategy, that is minimizing the maximum loss. Considering the entries in the column maximum row, company B can be guaranteed a decrease in market share of no more than 2% by selecting B3. That is why this company will go for B3. Selecting B1, in case if the instead of choosing B3, if the company B go for B1, could result in a decrease in market share of 5%. If they go for, the company B go for B2, there is a decrease in 4%. So, that is why company B will stick to play with the strategy B3. If the company goes other than B3, there is a more loss for company B. After comparing the column maximum values, company B selects the strategy that provides the minimum of column maximum values, that is called minimax. So, this is called minimax strategy. Thus, company B selects B3 as a best optimal strategy. So, company A will go for A1, okay, that intersection value is 2, the 2 represents the value of the game. Company B has a guaranteed that the company A cannot gain more than 2% in the market share. Now, this is called identifying a pure strategy solution. If it is optimal for both players to select one strategy and stay with the strategy regardless of what other player does, the game has pure strategy solutions. Whenever the maximum of row minimum is equal to the minimum of column maximum, the players cannot improve their payoff by changing to a different strategy. Then the game is said to have a saddle point or equilibrium point. So, a pure strategy is the optimal strategy for the players, because the value of maximum and minimax is same. Yeah, this location, this is called a saddle point or equilibrium point. Why? Because the value of maximum equal to minimax. Suppose changing the strategy for player B. When a company A selects a pure strategy A1, let us see what happens if the company B try to change from its pure strategy B3. Company A's market share will increase by 4% if the company go for B1. Will increase 3% okay, if the company go for B2. So, company B must stay with its pure strategy B3 to limit companies A to a 2% increase in the market share. Since this fellow has fixed here, he cannot go to B2, B3. If he moves other than B3, that is B2, B3, so there will be a more gain for company A and more loss for company B. Similarly, with the company B selects its pure strategy B3, let us see what happens if the company A tries to change from its pure strategy A1. So, this B3 is fixed. If the company A is fixed A1, in case if he moves to other options, for example, A2, A3, if the company A's market share will increase only 1%, okay, if you go for A2, and will not increase at all if you go for A3, 1 0. Company A must stay with the pure strategy A1 in order to keep its 2% increase in the market share. Thus, even if one of the companies discovers its opponent's pure strategy in advance, neither company can gain any advantage by switching from its pure strategy. Because if you know the pure strategy, whether the company A and B, they cannot move, they cannot switch over their strategy. If they switch over, that will not be beneficial for them. Now, what are the steps? Okay. Steps can be used to determine when the game has a pure strategy. What is the step 1? Compute the minimum payoff for each row. For player A, select the strategy that provides maximum of row minimum, that is called maximum. Then compute the maximum payoff each column for player B. Okay. For player B, select the strategy that provides minimum of column maximum, that is called minimax. Minimax. Company B play with the strategy called minimax. Company A is playing with strategy called maximum. If the maximum of row minimum, that is called maximum, is equal to the minimum of column maximum, minimax, this value is the value of the game and pure strategy solution exists. So, the optimal pure strategy for player A is identified in step 2 and the optimal pure strategy for player B is identified in step 4. These are the steps. So far we have seen the pure strategy, but there may be a situation the maximum may not be equal to minimax. So, the same matrix there are small modification is done. What is small modification? Here we change the value, instead of go back, instead of 0 we put the 5. Now, I am going to follow the same strategy. What we will do? Row minimum 2, so -1 -2, okay. In that which is maximum, 2 is maximum. Then you will go for minimax. So, maximum is 5, 4, 5. Here the minimax is 4. So, this situation you see that here it is different, the maximum is 2, minimax is 4. So, we can see the pure strategy is not existing, only the mixed strategy exists. With a mixed strategy, each player selects its strategy according to the probability distributions. What is the meaning? Player A has 3 strategy, player A. So, A1, A2, A3. So, instead of previously the player A was sticking with the strategy A1, stick with the strategy A1. Now, he is going to play the strategy with the help of certain probability distributions. What is the probability? Sometime he may play with say 50%, 40%, maybe 10%. Like that he is going to follow a particular distribution while choosing a strategy. So, in the market share example, each company will first determine an optimal probability distribution for selecting whether to increase advertising, provide quantity discounts or extend the warranty. So, this probability distributions we are going to find out. Then the game is played, each company will use its probability distribution to randomly select one of its 3 strategy. So, this strategy is called pure strategy. Now, we are going to look at the problem of the pure mixed strategy from the point of view of company A. Company A will select one of its 3 strategies based on following probabilities. So, we are going to call PA1 probability that the company A selects strategy A1, PA2 the probability that company A selects strategy A2, PA3 the probability that company A selects A3. Using these probabilities, like this fellow is going to play PA, PA1, PA2, PA3. Similarly, the player B is going to play with the probability PB1, PB2, PB3. Okay. Using these probabilities for company A's mixed strategy, what happens if the company B selects B1? If the company go for B1, what will happen to the company A? Using the payoff in the B1 column of the table, we see company A will experience an increase in market share of 4%, this one, with the probability of PA1, and the decrease in market share of 1%, this -1, with the probability of PA2, and an increase in market share of 5% with the probability of PA3. So, the expected gain, okay, for company A, if company B plays B1, the expected gain, okay, if the P play B1 is equal to 4 PA1 minus just probability and corresponding the expected value, okay, probability and multiplied by the payoff value. Okay. We know the expectation, in probability context we know that E of x equal to sigma of x into P of x. P of x is the probability PA1, PA2, PA3, the x value is 4 minus 1, 5, then we have to sum it. Now, the expected gain in market share for company A for each company's B strategies. If the company go for B1, the expected gain for company A is, we have seen just now. If the company go for B2, what is the expected gain for company A? We know this is PA1, PA2, PA3. So, 3 PA1 plus 4 PA2 minus 2 PA3. So, if the company B go for B3, what is the expected gain for A? 2 PA1 plus 1 PA2 plus 5 PA3. We know that the company A will play with strategy called maximum. Okay. So, given the probabilities PA1, PA2 and PA3 and the expected gain expression in table, so game theory assume that the company B will select a strategy that provides minimum expected gain for company A, because B will restrict the gain of A. So, the company B will select B1, B2 or B3 based on the expected gain of A. So, the company B will select the minimum of expected gain of B1, expected gain of B2, expected gain of B3. Okay. Now, here we are going to introduce a new decision variables called gain A. What is the meaning of this gain A? Define gain A to be the optimal expected gain in market share for company A. Because company B will select a strategy that minimizes the expected gain, we know that gain A is equal to minimum of this EGB1, EGB2, EGB3. Thus, the individual expected gain, what do you say, EGB1, EGB2, EGB3 must be greater than or equal to the gain A. If the company B selects B1, we know the expected gain B1 should be greater than or equal to gain A. So, company's A's optimal mixed strategy. So, this is minimum of expected gain when the company go for B1, this company go for B2, when B go for B3. So, this is company B will select a strategy to minimize the expected gain for company A, but company A will seek to maximize the minimum expected gain company B can obtain. So, that is why it is called maximum. So, company B will go for minimum of these values, but company A will try to maximize the minimum value. So, here the objective function is very important, it is a maximizing gain A. Okay. So, what are the constraints? Just now we have seen for each constraint it should be greater than or equal to gain A, because company A will go for maximizing minimum gains. So, that is why it is greater than. If the company go for strategy B1, A will try to maximize the minimum gain. If the company go for B2, B go for B2, the company A will try to maximize the minimum gain. At the end, apart from this, we have to add sum of probability should be 1. This when I solve it, now I have brought our LP model. So, when we are solving this game theory mixed strategy in A's perspective, you should remember this objective function is maximization function. All the constraints should be greater than or equal to gain A, because this is a maximum strategy. So, here the decision variable is written D5 to DG. I have entered all the constraints as usual. Then I have formulated the this spreadsheet model. Now, I am going to solver. Look at here that I did not write the objective function separately, because objective function the value of. So, the objective function is D5. So, I did not write a separate cell for that, but I am going to select the objective function is D5, because that is what we want to maximize. Changing cell I have selected. There are two constraints, all the constraints are greater than or equal to one constraint, the sum of probability should be 1. So, when I solve it, answer sensitivity limit. When I solve it, the value of this game is 2.375. See the PA1 E5, the value of PA1 is 0.875, the PA2 is 0, PA3 is 0.125. So, what we are inferring from this output is the value of the game is 2.375 if 87.5 percentage of time company A should go for A1 strategy, 12.5 percentage of time company A should go for A3. So, company A need not play with A2. If they play with this kind of probability distribution, the gain for company A is 2.375, that is the interpretation. Now, I have brought the Excel output here. From here we can see the value of PA1 0.875, PA2 is 0, PA3 is 0.125. When I substitute these values in the first equation, that says if the player B plays B1, the expected gain for A is EGB1, that is 4.125. The second one is 2.375, the third one is 2.375. We know that the player B will try to minimize A's gain. So, the player B will try to stick to B2 and B3, because that will minimize the A's gain. But even though the player B plays with B2, B3, the gain for the player A is 2.375. Company B will minimize company A's expected gain by selecting either B2, B3. However, company A has selected its optimal mixture strategy by maximizing this minimum expected gain. How it has selected? Because we have given some probability PA1, PA2, PA3. Okay. So, if the company A play with this probability distributions, whatever strategy chosen by B2, B3, there will be a gain of 2.375 percentage for player A. Thus, company A obtains an expected gain in market share of 2.375 percentage regardless of the strategy selected by company B. So, the mixed strategy what we are suggesting for company A is PA1 0.875, PA2 0, PA3 0.125 is the optimal strategy for company A. The expected gain of 2.375 percentage is better than the company's A's best strategy A1, which provides a 2 percentage increase in market share. When the company plays with a pure strategy, the market share is only 2 percentage. But when the player A play with the mixed strategy, what is that mixed strategy? So, this strategy A1 has to be played 87.5 percentage of time, this is 0. The strategy A3 has to be played 12.5 percentage. So, if we follow this mixed strategy, the gain is 2.375 instead of playing a pure strategy. So, in this lecture I have introduced the concept of game theory, I have discussed about the pure strategy, then I have started about the mixed strategy also. That mixed strategy problem I have formulated in the form of linear programming problem, then I have solved with the help of solver. So, I have interpreted the result in the perspective of player A. The next class, the same problem, I am going to solve this problem in the perspective of player B. Thank you very much.